In light of this idea of base of support, I wanted to show you how you can use this idea in problem solving as well if you want to. You can solve any problems just using torque. That's kind of the more physicsy way to do it. But we also now have this concept that something will only be at static equilibrium under the influence of gravity if its center of mass is over its base of support. So let's see if we can use that to solve the same problem that we solved a couple of different ways using kind of more direct torque-based methods. So we have this problem with a meter stick balancing on a narrow support. This object's base of support is this one very narrow point here. That's the object's base of support. So if I treat the two blocks and the meter stick as a combined system, if I can find the center of mass of that combined system, if this thing is going to be at static equilibrium, the combined mass has to be directly over the base of support. So basically, remember this formula I mentioned kind of briefly in one of the previous videos and didn't use too much, that the location of a system's center of mass is m1x1 plus m2x2 plus m3x3 in the case of a three-object system, which is what we have here, over m1 plus m2 plus m3. So that's how we would locate the system's center of mass. Let's do this, and we will force the object's center of mass to go over the base of support, and we'll end up getting the correct answer that we should get. Okay, so let's say, I'm going to say x equals 0 is going to be the left end of the rod here for calculating all these x values. So that means the location of the center of mass, I'm going to force that to be the location x shown in the picture. So the object's center of mass must end up being located here over the base of support. That's the physics. Then we've got m1x1. That will be, let's just do them from left to right. I'll have 0.2 kilograms times 0. This one's located at x equals 0. Then we've got the stick itself is 0.15 kg, and that's located at x equals 0.5 meters. And then we have M3 is 0.1 kg, and that's located at x equals 1 meters. And then we divide that by 0.2 plus 0.1 plus 0.15 is 0.45. And that gives me, it should give me the same answer that I got using the torque-based method that I did previously. So we have 0.15 times 0.5 plus 0.1 divided by 0.45, and we get 0.39, which is the same answer that I got using two different methods in the previous videos. So that's another thing you can do with the idea of center of mass and base of support is if there's no external forces that are trying to push the object over and everything, the only reason it's going to tip over is because of gravity, you can say that it will tip over only if its center of mass goes outside the base of support and solve it that way.